Welcome. I'm Diana Wong, a product manager working on developer experiences for adaptive apps across form factors.
And I'm Emilie Roberts, a developer. Oh my goodness, you guys! That was a plant. I planted some people for that. No.
Yeah.
I'm a developer relations engineer working on ChromeOS and adaptive apps. And today, during this talk and at I/O, you're going to hear the word adaptive a lot. Adaptive is not about developing for a tablet or a foldable or any particular form factor at all. It's much more than that. It's about thinking beyond form factors and developing for robust, reliable app experiences that meet your users' expectations on all the screens. If I give my mom a tablet, she doesn't want to think about, why does this app stretch off the screen and I can't take a photo with it? She just wants to do some cool stuff with it.
The reality is that our users are not on a single device. They might start a task on a foldable, move to a tablet at their desk, and finish on a laptop, expecting that experience to flow seamlessly across every surface. Users, like Emilie's mom, don't always think about form factors. They think this app works or this app doesn't. And we've been working to improve our frameworks and libraries to help your apps run great across the ecosystem. We hope you can adopt this adaptive mentality too.
And all these form factors bring lots of exciting opportunities for you and some new considerations. So today we're going to talk about the Android ecosystem, how it's expanding with some exciting new form factors, new APIs and updates to Jetpack Compose. We're going to look at tools, including adaptive AI skills, and at the end we'll look at a few UI frameworks that you can use to bring your existing app to Android. We're also going to sprinkle in a surprisingly large amount of French pastry and a wrap, maybe? So let's get started.
It's going to be good. Let's start with a brief overview of the ecosystem and where it's headed. The Android device universe is no longer a phone-only story. Users are buying into ecosystems using multiple Android devices, and they expect your app to follow them without missing a beat. There are now over 580 million large-screen active devices that benefit from investments in adaptive apps. And as we expand the surfaces that your apps can run on, that number continues to grow. It's not just the number of potential users, it's also that we've seen users that have multiple devices spend more. Users with a large screen, like a tablet or a laptop and a phone, spend 9 times more than phone-only users. And for those that are on foldables, that multiplier jumps to 14x, making it one of the highest value user segments on Android. Play is helping to increase that opportunity for installs and spend by letting users know which apps work best across devices. Apps that are optimized for large screens now feature an Optimized for Large Screens badge on their details page. And since last year, more apps have continued to go adaptive. Here are some great examples of apps that deliver premium experiences across Android. I'm going to dive into a couple, like Notability. Their Android debut sets a new standard for premium productivity apps. Built with Jetpack Compose, Navigation 3, and Kotlin multi-platform, it delivers an intuitive, adaptive experience across devices. It also features great stylus support with the low-latency Ink API. Another example is BandLab, a full-featured collaborative digital audio workstation. Users can create digital music and record a live performance in a multi-track environment. And when a device has a trackpad and the screen space, users want to be able to take advantage of it. Leveraging Compose, BandLab rewrote their portrait social feed so that now it can expand into a masonry-style, multi-column look that makes the app feel right on wider screens. The great thing about adaptive development is that every optimization you make naturally enhances the experience across devices. Last year, we introduced changes for all apps so they default to adaptive behavior, removing letterboxing on devices. We provided a developer opt-out behind Target SDK to give apps time to adjust, and now with Android 17, the opt-out is being removed when apps target SDK 37. On large-screen devices with the smallest width over 600 dp, like tablets, laptops, and the inner screen of foldables and XR, Android won't react to certain mobile constraints, moving closer to responsive UI development. These include changes to how apps react to set orientation, or resizability, and aspect ratio. So note that these restrictions are still respected on smaller screens like phones and for games, and we're continuing to move. You can prepare by having your apps naturally adapt and look great in whatever window they're placed in, not just a 16:9 phone. Things to watch for are stretched UIs, squashed or sideways camera previews, off-screen controls or animations, and your app's state after a rotation or a folding or a resize event. Be sure to test your apps to see how they will show up for your users with these changes using a compatible emulator. If you don't have an Android 17 device, you can still test on an existing older SDK by going to Developer Options and selecting App Compatibility Options. If you look under SDK 36 and you enable the Universal Resizable by Default flag. So these Android changes help pave the way for the evolving Android ecosystem. Let's check out what's new across our Android form factors. As we announced earlier this year, connected displays is now publicly available with the recent Android feature drop. This means any compatible Android phone or tablet can instantly be transformed into a powerful productivity hub by plugging it into an external display. This is already available on supported Pixel and Samsung Galaxy phones, and it brings compatible phone and tablet users into the desktop world of increased engagement time without the need for an additional device. Apps that are adaptive and handle mouse and keyboard inputs are going to stand out. And that's not all for desktop. If you tuned into the Android show last week, you'll know that Android will support one of the most popular computing form factors, laptops.
So Android apps have been a first-class citizen on Chromebooks for a decade. And of course, building adaptively for Android, meaning awesome large screen layouts and top-notch input support, remains the very best way to make sure your app looks great on laptops. And on the hardware side, you know we've continued to iterate, like with more powerful Chromebook Plus devices. And so you can imagine how excited I am to stand here and talk about the next iteration of ChromeOS, built on pieces of the Android stack, also known as Google Book! I know it was already announced, but I'm still super excited about it. The new name and the incredible lineup of devices we have coming from a variety of OEMs represents a shift in computing. The next iteration is going to make for powerful laptop experiences running the exact same apps that billions of mobile users depend on every day with Android. This is a milestone, and we should celebrate it. But I also think it's worth mentioning that it's a continuous evolution. We're bringing years of innovations and learning from ChromeOS to improve the experiences of ChromeOS and Android users across the board, not just on laptops. Some of this is already visible for phone and tablet users. For example, the Chrome browser on tablets has the bookmark bar, as shown here. And phones and tablets also have pinned tabs and connected display support. And the improvements go both ways. The next generation of Chromebooks, or ChromeOS, is also getting a boost. Right away, you'll notice a performance boost for your Android apps. It also allows us to bring you the power of Gemini right into your laptop workflows, unlocking whole new desktop user journeys. So I wish I could say a whole bunch more about Google Book and all the awesome devices coming and all the juicy technical details. But the most important thing is that your apps are ready. And one way to start testing for that is with the new desktop emulator that is now available in Android Studio Canary, Quail Canary 4, I believe. And you can find it in the Virtual Device Manager under Desktop Preview. And just make sure it says SDK 37, and you should get that resizing experience happening. On the documentation side, to help prepare for Google Books, we've built out new guidelines on developer.android.com and material.io, including design kits that cover desktop-focused principles, new input guidance on things I love, like right-clicks and hover states, and more opinionated guidance about layouts. One of the documentation updates I just want to share is something that happens when you have Android apps running on these larger screens with pointer input. Sometimes information density can make an app feel right on a desktop. So with larger screens and a precise pointer, sometimes having slightly more dense UI just makes the look and feel better. It can be really subtle, like the padding and button size as shown here in this mock. And lastly, as Diana mentioned, with all these new Android devices coming, users are more likely to have more than one of them. Continue On is the new API in the activity class coming in Android 17, which allows users to pick up where they left off on a second device after they have been working on a first one. So you can see on the phone here, Google Docs, we're way down in a document tab, and we're scrolled way down. And so to continue editing on a tablet would be a little bit frustrating to find that exact place. Continue On allows you to pass the data off, and the user can pick off right where they left off, come on GIF, right in the document tab, and scrolled right down into the document. To integrate and make sure your app is ready for Android 17, indicate you support Continue On by setting handoff enabled to true, and then you just set up and handle that bundle on the launch intent. And that's basically all you need to get integrating. To learn more about Continue On and these other desktop updates, check out this recorded talk dedicated to that. Of course, designing for desktop means your app's going to work great across a whole bunch of the Android form factors. So let's talk a bit about those.
So looking at another class of devices where making your app adaptive can help, the in-car app experience is a perfect example of how these changes apply to car displays. Whether it's catching up on content or staying productive, users can enjoy their favorite mobile experiences the moment the vehicle is parked. If your app is already adaptive, that's great, you're almost there. For Android Auto, meaning your mobile device is running the app but the UI projects onto the in-car display, you can add an appropriate manifest entry and check for eligibility details in the Android Auto docs. For Automotive OS, which is when your app is installed in the car's embedded infotainment system, your UI scales up easily like a tablet. There are a few more things to check to make sure your app can be installed in addition to those automotive-specific manifest flags. So first, check your manifest for these features. Of course, your app can still take advantage of these features on devices that support them, but if your app doesn't need them to run, you can indicate that with required equals false. Secondly, you check your dependencies on Google services. Many of the Google Play libraries you use on mobile are also available on cars, but not all, and you can check the docs to see if you're inadvertently including a library. Another form factor that benefits from adaptive development is TV, where Android apps are getting new types of input support. Google TV supports pointing input with cursors, trackpad, and now pointer remotes for faster navigation. Think of this as a direct extension of the work you're already doing to support inputs beyond touch, like on Google Books. By implementing hover states and focal points today, you aren't just optimizing for a mouse or a laptop, you're making your app inherently compatible with the TV interactions of tomorrow. Next, Android XR continues to heat up with new devices and a growing user base. Like other form factors, your existing adaptive app will be available on XR. With optimized large screen layouts and excellent keyboard and pointer support, your app can provide an immersive experience across XR headsets and wired XR glasses. Starting from these adaptive best practices, you can also add immersive spatial capabilities for XR, as well as creating unique on-the-go augmented experiences for audio and display glasses. This is where the Android XR SDK comes in, helping you build these differentiated experiences. And you can learn more about creating both immersive and augmented experiences in the Android XR recorded talk. So that's what's new across our devices and the exciting changes we're enabling for each of them. But what's the best way to build for all of these exciting form factors? It starts with our Jetpack and Compose APIs.
So this year at I/O, we announced we're going Compose first. And Compose is the best way to build adaptive apps. Let's look at 3 important topics when building adaptively, and we'll start with layouts. Instead of designing apps for a specific form factor, design for UI capabilities. That means things like allowing your app to dynamically react to if there's pointer or keyboard, window size, posture changes like unfolding or folding, or detachables, or hardware capabilities like if there's a microphone or a camera available. And we know that not every developer has the same needs, and so we have options for how you approach different pieces of your UI. Sometimes you might want this piece of your UI to have an out-of-the-box solution that just works. Maybe you want something that has a basic implementation, but you want to customize it. And finally, you might want to build some components right from scratch for a bespoke look. An example of those ready-made APIs is the Compose Material 3 adaptive library. It has 3 different adaptive layouts, including the navigation suite scaffold. This is an out-of-the-box solution to help you handle navigation UI, allowing you to have a navigation bar on the bottom on narrow screens, and then a nav rail or a nav drawer on a wider one. For multi-pane layouts, you can use Navigation 3 with material scenes. If your app follows the list detail paradigm, there's list detail scene, which automatically handles multi-pane arrangements based on screen size. There's also supporting pane scene, which helps show additional supporting info that's related to that main content when the screen's large enough, like the up next shown here. Moving on to customizable APIs, which provide a more flexible middle ground, you can take these existing implementations and then modify them to suit their needs. Let's take a look at an example with scene decorators. Scene decorators in Navigation 3 1.1 allow you to wrap your UI content with custom elements. You could use this to add aesthetic touches, or you could use scene decorators to implement the navigation UI, like bottom bars and side rails, but with an important distinction with the navigation suite scaffold we just talked about. With scene decorators, you can allow your content to drive when that decorator should be shown or not. This is particularly helpful in cases where you might have some app flows where you don't want the decorators. So maybe a camera preview screen that you want in a dialog, or full screen and you don't want the nav bars shown, and you can do this without having to manage the state up and down the stack. For some ready-to-use but customizable implementations for scene decorators, check out the Nav3 recipes page. Now, if you wanted to do scene decoration but get right into the details and build from scratch, you can do that too. Implement a scene decorator strategy, override decorate scene, and then you can decide based on the content if the scene should be decorated, in which case you return that decorated scene, or else you return the undecorated scene. Let's take one more example of this customizable versus build from scratch with scene strategies. To let Nav Display know when to show which scene, we introduced scene strategies in Nav 3 1.0, and it lets you determine when to show each scene based on your own custom criteria. Our Navigation 3 recipe page again has some customizable scene strategies for you to use and customize. If you wanted to go farther, you have that control tool, and you can really customize down to the animation speed and add all that into your own scenes. And one update I wanted to mention quickly about scene strategies is we updated the API to be plural. And it now explicitly takes in a list of scene strategies in prioritized order instead of you having to use that undocumented then infix like in 1.0. This should hopefully help you more easily implement complex scene strategies. Okay, so I know I just threw out a bunch of APIs and just skimmed the surface on them, but to learn more about scene strategies, scene decorators, and what else is new in Nav 3, check out this dedicated recorded talk. Outside of Nav 3 itself, we have some new APIs too. Gathering conditions to determine which of those scene strategies to show can be difficult. The experimental media query API for Compose provides a declarative way for you to get signals from the environment, like window size or pointer precision, and make decisions based on that. This API is going to grow, and we need your input. So check it out and let us know what you think and what's missing and what's working well. Media Query was inspired from CSS, and we have 2 more APIs, experimental APIs inspired by the web. I know some of you have been asking for these for years, so I'm happy to let you know we have grid and flexbox layouts. Yay! Yeah. So grid is for creating 2-dimensional layouts. Let's dig in a little bit. And I know our talk is full of information, and everybody wants to talk about pastries. I live in Paris, and I love the pastries there. So I'm going to my favorite vegan bakery, which unfortunately is below the office, so I go there quite often. And I want to lay out some patisseries in a box, and I'm going to bring them to a party. OK, it's a square box. Let's say it has room for 4 pastries in each direction. It's a grid. To set that up, in the config block, I use the repeat word to set up 4 columns and 4 rows. Are you ready for my incredible drawing skills?
I'm so ready.
Let's start with a baguette. Yoo-hoo! So you can see that it spans 4 columns and 1 row. Let's add a few more treats into my box. We have an opéra, which is 2 rows, 1 column, a tarte au citron, which is 2 by 2. And then let's add a few more little regular pastries. A chausson aux pommes, that's my favorite. It means apple slipper. So you can imagine like a slipper stuffed full of warm apple insides. And a chocolatine, also officially known as a pain au chocolat. But I'm from Canada, so there you have it, chocolatine. Lastly, just to finish this off, let's add 2 giant-sized declares there that are 2 columns each.
OK, this looks really good as pastries, but I'm assuming you're imagining these are really toolbars and buttons in real app life.
Yes, of course. Pastries are more fun, but maybe that's a title, maybe it's a button. Yeah, but come on, pastries. You can all build pastry-based apps after this talk, no problem.
I'll take the eclairs. Yeah. Oh, go ahead.
Well, this is grid, and it provides this amazing resizable UI, and it looks good. I think everyone's going to be pretty happy about that, right?
Yeah, they look too good to be true. So are they really going to scale?
You don't believe this is what's happened? There's only one way to settle this, with a live demo. OK, let's go to a live demo of grid and Flexbox here. This is the app. This is the app running on my Chromebook, so it's running natively here. And check it out. It resizes. Hold on. Come on, mouse. OK. Resizes, stretch, looks nice. Look, I got a little blog here about me in Paris, Canadian in Paris. Oh, I added this here's just showing that density thing I was talking about, but we'll leave on normal density. OK, this is grid. Great. I would like to talk about the second API, which is Flexbox. And let's look in the code. Here's my grid code. Here's the code we just saw, but let's talk about Flexbox. Flexbox lays things out, wait, it should go this way, right? In a single direction, and it has 2 modes, one that allows for wrapping and one that doesn't. So let us start with no wrapping to start off with. I've got 3 little things here, chocolatine, baguette, and let's run this and hope it works. Of course it'll work. All right, so here we have 3 elements. They're all affixed with, and they work great. You can click, oh, I forgot to talk about, if you click on this, hold on.
It's a beautiful new Compose Flower Puff API.
Flower Puff 1.0 in Compose. Just kidding. OK, let's get serious.
Going to stable now.
Going to stable now. It's available today. OK, that was a joke, right? But this baguette, this is the baguette, and look how tiny it is. It's all squashed in the middle. Your UI team is going to say, hey, don't you think we should fill up that space? Well, this is called Flexbox, so guess what? We're in luck. I'm just going to uncomment this line and comment, oops, getting a little nervous here. OK, comment this line out here. So here, I'm keeping the height fixed, and I'm allowing the width to flex and grow up to 100% of the leftover space. That's what that float value is. And with any luck, come on, Android Studio, we need you. It will stretch and grow to fill up that space. And let's just double check. There it goes. Look at that sourdough baguette expanding. So you can again imagine this is like a button that you don't want to have changing size in your UI, but maybe that baguette is a title bar or something like that. So this is Flexbox in the no wrap mode, and I think it's time to wrap.
I think in honor of wrapping here, just to be clear, Emilie has written a rap about adaptive. I'm really kicking this off.
Yeah, maybe I've written a rap.
Making apps is cool. I do it in my sleep. I'm so adaptive. It's gonna make you weep.
All right. That's pretty good. Not too bad.
Too bad.
Pastries in a box while I'm wrapping around the clock. Flex boxing like my pipes while I'm coding as I type. So.
More.
My keyboards, they be clacking when my trackpads, they be whacking. Stylus ink API like lightning. Man, my drawing's so bad, they're frightening. I got my data in the cloud, but local storage all in shroud in aluminium. Yo, we be winning them. Hold on. No. Take a oogly look at my googly book. A grid may be square, but avec baguette ou éclair. Adaptive is rising, my UIs be sizing from Android TV, foldables, tablets, laptops, cars, phones, right down to Android Wear.
Okay. That was great.
That was good.
Let's get back to something serious like pastry.
Yeah, pastries, let's get back to the pastries. Oh, I blanked on my favorite
All right,
line.
so we're back in flex mode, and now wrap is turned on.
Oh, here's wrap. We have wrap turned on here. Let's see. Oh, wait, I'm just going to change my view model here to make this easier. OK, so we are in, remember, Flexbox lays out in one direction. When we don't have any room here, we've added a baguette and a little chausson en pomme. It wraps down to the next line. OK, no problem. So let me uncomment out a few more pastries here. And when it runs out of room, here we've got this eclair, we've got a tart, and remember that chocolatine is one. It falls off the end and wraps down to the other side. So that's as we expect. Let me just show you one last thing. What happens when we have Flexbox wrapping all those lines and it doesn't line up perfectly? So here I've got this nice eclair, and it fills up 3 columns. There's no room for here. And that last eclair, we don't want to have it all squashed in the box with the filling coming out, so we wrap it to the next line. This is just like you want.
Yeah, I need more eclair, though.
Yeah, more eclair, but you've got a pastry box with empty space in it, which is a problem. And your UI team might say, I don't know about all this empty space we've got going on. So let's look at an option we have. What have I done with that? Let's just assume that's going to work. That'll work. Let me fix the height, but let me go back to the code. Let that width flex and grow like we did before for these 2 eclairs and see what happens. And there you have it. The eclairs stretch out nicely. Flexbox is smart enough to know, look how giant those are. Flexbox is smart enough to know how much space, even though we're wrapping, is left on that row, and it expands nicely. OK, we're almost done with the pastries, I promise. Not that that's a good thing. But let's say the artist, that's me, is not impressed with the fact that we've stretched out that artwork. Design team's sort of happy, but it just doesn't look right. The aspect ratio is all squished. Let's see what happens if we unbind the height and let these grow. Look at this giant eclair there.
Definitely more eclair.
It's definitely more eclair. The artist is happy. The UI team is happy if you like pastries. And I've let both the height and width flex and grow up to 100% of the width. That was a lot of pastries.
Yeah. Compose is where it's at.
And those pastries are fat. P-H-A-T, like the 90s.
That's our wrap for you guys.
That's a wrap for that. Thank you.
It's a long talk. All right. So adaptive layouts, even the stretchy ones with pastry, are only one piece of the puzzle. Excellent non-touch input support is a must, and we've made framework-level investments to provide more out-of-the-box experiences. In Compose 1.11, we've improved trackpad support to be on par with mouse and pointer support, including proper hovering and tooltips. We now process trackpad events as pointer-type.mouse events, ensuring consistent behavior across pointer devices. This enables automatic recognition of advanced gestures such as pinch to zoom and two-finger swipes. We've also shipped new non-touch-based input testing APIs in Compose 1.11, including trackpad injection scope and perform trackpad input. This helps you write reliable automated tests for non-touch input. Focus states are also important to input, and now in alpha, we've introduced support for focus rings designed for Material 3 components. Focus rings are a critical redesign of the Focus UI on Android, ensuring that interactive elements pop out for users during keyboard or D-pad navigation. Visual feedback is great for indicating focus, but we can do more, like visually indicating when an element is pressed or has a cursor hovering over it. That's so helpful for non-touch interfaces like Google Books and TV. So we now have an experimental API that allows for state-based styling. You can update visual properties of a component using the current interaction state, like when the component is pressed or hovered using the new Styles API. You can dive deeper into this and other dynamic ways that Styles and Compose can make your app adapt to different device characteristics in the live talk about the new Style API. Let's also talk about stylus support. So last year, we announced the Jetpack Ink API. It's designed specifically to bring high-performance, low-latency inking to the broader Android ecosystem. Now in stable, the API helps you get set up by handling geometry calculations, accessing low-latency hardware compositor pathways, rendering with custom brushes, and even serializing your inking paths. We also have an open-source demo app which showcases how to make the most of the stylus, Kaye, showing it in action. You can check it out on GitHub, and don't miss the dedicated recorded talk to help get fast, beautiful stylus support into your app. Finally, we need to talk about camera previews.
Absolutely. If I'm getting pastries and taking photos of them, I need the camera preview to be perfect and get the lighting and the angle just right?
So when we look at devices beyond phones, camera previews are one of the biggest sources of compatibility issues. They often appear stretched, cropped, or sideways. And this happens when apps assume a fixed portrait-only preview. It simply doesn't hold true all the time. The recommended solution is Jetpack Camera X. The Camera X viewfinder component is built specifically for adaptive apps, automatically handling the calculations for sensor orientation, device rotation, and aspect ratio. This ensures your camera preview looks correct. And if you're wondering about implementation, just hold that thought. In a few moments, we'll show you how we're making it simple to migrate to Camera X. You can learn more about Camera X and some of the new APIs in this recorded talk. And that was just a bunch of exciting new APIs and libraries, all to help you get ready for Android 17, with a lot of them giving you adaptive behaviors out of the box. Still, we know it's a lot to keep track of, which is why we're working on tools to make it as seamless as possible for you to integrate. One of the fastest ways is to use AI directly inside Android Studio. Iterate quickly from within the IDE as the agent helps you architect and build your app. One thing that's particularly relevant are specific Android skills we've been building. And skills are modular instructions to help LLMs execute best practices and workflows. The examples of adaptive focus skills that you can try are a views to compose migration skills. So this is the first step to getting your app ready for adaptive. Let Gemini do the heavy lifting. We've talked about the benefits of Navigation 3. If you're ready to update, we have a Navigation 2 to Navigation 3 migration skill. And for those stretched and squashed camera preview issues we mentioned, Camera X can fix them. And we have a Camera 1 to Camera X skill to have all those state changes handled automatically. So let's take a look at that skill in action. Camera 1 has been deprecated for years, but it's still used. Here's what a naive implementation looks like on a modern foldable. So you notice it's stretched and how elongated that glass puzzle piece looks. It gets worse as you rotate the device. The preview is not rotated, and the aspect ratio is still broken. So updating your viewfinder to fix this is not trivial. Depending on your implementation, you may need to manually handle camera lifecycle and juggle device configuration changes. It's easy to miss things like folds, window resizing, or external monitor events, and then accidentally get the geometry and sensor orientation calculations wrong. So you can watch our skill in action. Here we ask the agent to convert this camera 1 activity to a camera X using this skill. So the agent locates the skill, and it begins analyzing the project structure. If you're on camera 1, you're likely still using views and maybe Java, so it'll utilize preview view. If it detects a compose environment, it'll use the camera X viewfinder. And now into my favorite part of the skill, which is what not to do logic here, shown here under constraints. We've baked in best practices into the skill, like don't manage the lifecycle manually, don't forget to close the image proxy, and don't wrap the preview view in Android view unnecessarily. When you look at the diff, it replaced the legacy surface view with a modern preview view. It handled the lifecycle, and it also implemented some enhancements like tap to focus. So now let's see what that glass puzzle piece looks like. The camera preview is crisp, the aspect ratio is perfect, and most importantly, rotation, it just works. So just like that, you can modernize your viewfinder in your apps. And I'm realizing this could have been in Eclair. Yeah.
I know, missed opportunity, big missed opportunity.
These building blocks are crucial pieces of an adaptive app, and we're continuing to add more. In addition to these specific migration skills, we have created an overall adaptive skill that uses the recommended patterns and libraries we've talked about to update your existing app across any size screen. Beyond updating your existing app, we've also introduced the new project agent starting in Android Studio Panda to help build a working app prototype with just a single prompt. Every new project created with this agent is now optimized to be adaptive. So that was just a quick overview. There's a lot of power with these skills, and we have a full live talk about ways to use skills and other AI tools in Android Studio, so check that out. And following lunch, we have a talk specifically about using those AI tools to help make your app adaptive. So don't miss that, as there will be some great tips, demos, and examples.
So to close out, we want to talk about some other frameworks. If you're building a new Android app, or you're updating your existing views-based app to be more adaptive, Compose, Navigation 3, and all the tools we talked about today are the obvious choice. However, it's worth mentioning some other frameworks that can provide really great adaptive experiences. This can be especially important for those of you shipping on multiple platforms, and if you're looking at bringing your existing app to Android. I'm just going to touch quickly on 3 of them today. And let's talk about web first. If you have an existing web app that already looks great on desktop and mobile, it might be worth considering leveraging that existing code to get a jump start on Android. And some apps are doing this successfully already, like Canva, a top-notch digital content creation tool that's adaptive, it looks great across platforms. They use their existing desktop-compatible web UI and then plug right into the Android system APIs when it makes sense to provide really seamless user flows. The secret to doing this right and to making your cross-platform web experiences beautiful app experiences on Android is knowing when to plug into those Android system APIs and how to make that flow super seamless, and when to just let things stay purely web. Check out this recorded talk all about that. Do you already have a desktop or mobile app built on Qt and it's not on Android yet? Well, if you're thinking about bringing that app to the billions of Android users out there, you're in luck because Qt can build for Android. A number of successful apps built on Qt are already providing top-notch adaptive experiences. Check out Steinberg's Cubasis 3, a full-featured digital audio workstation, or DJ, a DJ app that works on device or with foldables or MIDI controllers and fill those concert halls with your awesome beats. Or Krita, a community-driven drawing app that's popular with manga or comic artists. And for your information, the files for this comic, Carrot and or Pepper and Carrot, with all the layers and how the work was made is available on the website by the artist, so check that out if you want. And the third and final framework I want to mention is popular with cross-platform games, Unity. However, it's also used for a number of interactive and graphics-heavy apps, allowing them to share a unified code base across platforms. So if you're using Unity, you can build for Android. Just remember, mouse and keyboard support, and of course, as always, test, especially things like folds and unfolds and rotations and resizes, and of course, mouse and keyboard. So if you're starting out fresh, Android APIs are the best choice. However, if you have an existing cross-platform app experience, one of these pathways might be a quick way to get started on Android.
OK, let's recap.
Let's do it.
The value of investing in the Android ecosystem continues to grow. It's everywhere on a plethora of screens. And our stats show increased engagement time and spend for adaptive apps. When you think Android, it's time to think beyond the phone. Connected displays allow any phone to connect to a monitor with a mouse and a keyboard input. The next iteration of ChromeOS, Google Books, continues to provide a large-screen mouse and keyboard experience that's more performant and powerful than ever. XR spaces are even larger and radically rethink app interaction. And now, with the orientation and resizability API changes in Android 17, it's the right time to make sure your app is there. We've got your back with great new Jetpack libraries, updated guidance, new developer tools, better testing tools, and emulator. And with awesome skills and AI capabilities built into Android Studio, optimizing your apps is easier than ever. So with that, the both of us would like to thank you for being here with us and being on the forefront of Android development. And we hope you learned more about making your app adaptive today, or at least you're hungry for a pastry now.
Hopefully both, pastries and adaptive. Yeah.
Thank you.
Thank you.